So number 8 is a little bit like number 7. What I'm going to do is I'm going to talk about the fact that ABX, I started the proof, but we'll explain it now. ABX is congruent to BAX. That's going to force these two to be the same. Okay, we're going to get that by base angles theorem. It's an isosceles triangle. So let's go through that process. Okay, so then AX is congruent to BX, and that's by base angles theorem. All right, from here it's pretty tricky. Whoops, base angles theorem. I missed that word. All right, pretty tricky how we continue. Basically, what I've got to do is I've got to convince somebody that because these are the same, the entire diagonals are the same. So what I'm going to have to use is the fact that the diagonals bisect each other in a rhombus. So I have to say that. AC and BD bisect each other. Oh, I missed a step. Oh, sorry. Before I can say that, I got to say that it's a rhombus. ABCD is a rhombus because it's given. Now I can say that the diagonals AC and BD bisect each other. So the diagonals of a rhombus bisect each other. All right. Now I would use this, to get BX congruent to XD and AX congruent to XC by definition of segment bisector. All right. Now, since AX is the same as AB, then all of the parts are congruent. So, so that's going to make AC congruent to BD. Okay? Now I can say ABCD is a square because it is a rhombus with congruent diagonals. It wasn't the perfect move here in number 6, but I got around it. It would have taken a lot of steps to do it another way, so that'll work. That should get full credit. I'm going to skip a few of these. There's a lot of proofs, so I'm going to skip those, and I'm going to jump right to 36. Very tricky problem here. So what we're going to do is we're going to map, or we're going to graph MT. Now, because of MATH, MT implies it's the diagonal. Okay? Because you're skipping a letter here. Now, the other diagonal, because it's a rhombus, so the other diagonal must be perpendicular. and pass through the midpoint of MT. Okay, so pretty challenging right there. Using given information, how do you know that your line contains diagonal? I'm kind of answering that right now. So, all right, so first I'm going to grab 0, -1, and 4, 6. MT. Okay, sorry I don't have a straight edge, but what I should do is connect those and find the midpoint. 4, that's going to be 4, so halfway is 2. Is that really 7? So I guess we've got to go 3 1/2. 1, 2, 3 1/2. So right there, the midpoint of MT is the point 2, 2 1/2. Looks like, right? Is that right? Could that be right? 2, 2 1/2? Not pretty. Okay. All right. So now our line that contains the other diagonal must pass through 2, 5. You know what we'll do? 2.5. We'll use point slope form. And slope must be negative reciprocal of MT's slope. Okay, MT's slope is right now 7/4. All right, so perpendicular to MT, slope will have to be -4/7. Now I'm going to use y minus y1 equals mx minus x1. That's called point slope form. So, and I'm not even going to reduce it. I'm just going to leave it however it works out. So y minus whatever y1 is. It's got to pass through this point. So I'm going to call y1 2.5. Now the m is -4/7 and x minus 2. So there it is. That's the equation. That's an equivalent equation to whatever they present. And that should be good enough. All right. So we're trying to prove that looks like it's suggesting that we prove diagonals of parallelogram bisect each other. All right, what we're saying is PT is congruent to RT, ST congruent to TQ. Oh, that's what we're trying to prove. You're given that the quadrilaterals are parallelogram. Okay. So let's just follow through. They're saying, let's get rid of this. So we've got to follow their proof. Okay. They're saying those are parallel and these are parallel. Definition of parallelogram, fine. All right, why are PQS congruent to R minus Q? Trying to follow their PQPR. Those two congruent. SRP. Okay, so that is alternate interior angles theorem. So let's go through and let's say PQ is congruent to SR. PS is congruent to QR. And that's because opposite sides of a parallelogram are congruent. All right. What could we use to establish triangle SRT, SRT, SRT? congruent to triangle QPT. What could we use? Looks like angle side angle to me. Yeah, so that's what they want there. Angle side angle, triangle congruence theorem. Okay, corresponding parts, they did it for us. Yeah, perfect. All right, good enough. The last one we're going to do today, yeah, 38. We'll just finish this off. We're not going to make a new video for it. All right, first off, this one should be good, but I noticed there was a mistake here, but I'll just do this. So I'm counting up the sides, the change in X and the change in Y. So I got a rise and run of 6 over 2. Right? I'm going to use slopes to show parallel. So the slope for PS, the slope M is a positive 6 over 2. If you need to reduce, I don't have to, it's 3 over 1. For QS, it looks like the same, sorry, QR, same slope. Didn't have to reduce. Now, that's your evidence. Your conclusion is PS is parallel to QR because their slopes are equal. Don't forget to summarize that. Okay. Next, show PS is congruent to PR. They're not. That should have been QR. We're going to have to use distance. So PS, length of PS, is going to be your evidence. It's going to be 6 squared plus 2 squared equals D squared. That's 40. Square root. So PS equals the square root of 40, the length does. And we'll do that for QR. Now we know it's going to be square root of 40. Same numbers, but we have to play the game a little bit here just to get credit. Okay, so square root of 40 equals D squared, and then QR is equal to the square root of 40. And it just asked us to show they were equal. PS is equal to QR because their lengths are equal. Gotta say that. Gotta say why. What kind of parallelogram is it? It should have asked, this was a mistake. It should have asked what kind of quadrilateral is it, it looks like. So it is a parallelogram is the answer. Because it has a pair of opposite sides that are both parallel and congruent. Now, if you collected other evidence, such as, PQ is parallel to SR, and you collected their slopes being 0, and you said, a different reason, that's fine. But the work here is leading us to one pair of opposite sides, parallel and congruent. Okay, so that's it for this review. I know I skipped a couple, but it was getting pretty crazy how much there was. So good luck on the test, and I hope everybody's well.